All right, we're going to talk about patterns and inductive reasoning today. So, inductive reasoning. Inductive reasoning is reasoning using patterns or examples to determine the next outcome. So, inductive reasoning is using what you see and what you have in front of you, not using prior data. Okay? So, here's my example. I have 3, 9, 27, 81. Can I now come up with my next value? Well, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, 81 times 3 is 243. So my next value would be 243 because I'm only using the information I have there. So here I have a circle, a triangle inside of a circle. I then have a square inside of a circle. And then a pentagon inside of a circle. So the next one I would expect, or if I would look here and I said, oh, okay, well, I could either say that the next one is a hexagon inside of a circle, or I could say, well, this has a square, the circle's inside of a square, and the square is inside of a circle. So maybe the next one is a hexagon with a circle in it, with a circle inside of that hexagon. So you're using only the information you have. All right. A conjecture. Conjecture is a conclusion you reach using inductive reasoning. Okay? So it's that conclusion. Okay, here's our first one here. Here's our second one. Here's our third. So could you make a conjecture based on these three images? Based on this image here, this one, okay? So there's a lot of different conjectures you might make. You might talk about how many parts there are of the circle. So this one, 2, 4, 6. You might talk about the number of lines going through, right? Okay? So we're probably going to use the number of lines and how many pieces there are. Okay, so RWB, can you make a conjecture there? Your conjecture might be, oh, well, it's RWB repeating, RWB. Up here, your conjecture might be every time we add a line, we then add 2 more to the number of sections inside of it. Right? So collecting information to make a conjecture. So here we have the number of terms. So term 1, 2, 3, and 4. And so we look here and we have 2. 2 plus 4 is 6. 2 plus 4 plus 6 is 12. 2 plus 4 plus 6 plus 8 is 20. And if we look here, 2, a way we could get 2 is 1 times 2. And then 6 would be 2 times 3. 12 would be 3 times 4. 20 would be 4 times 5. So our conjecture might be n times n plus 1, right? Because here's our n. This is the number we're starting with. Here's our next one, so the next one on there. Skip over that. So kind of go back here. This problem here is actually asking you to make a conjecture based on a graph. So, and I think you guys can all do that. A counterexample is an example that shows that a conjecture is incorrect. So it's a statement that's going to show that it is false. So for example, I might say all primes are odd numbers, right? Well, my counterexample would be 2. 2 is a prime, it's not odd, so therefore that statement is incorrect. Okay? If the name of a month starts with the letter J, it is a summer month. Well, do we have a month that starts with the letter J that is not a summer month? Well, if we're in the northern hemisphere, we have January. January starts with J. January is in the winter. If we're in the southern hemisphere, we'd have June and July. You can connect any 3 points to form a triangle. Okay? Could you give me an example that proves that that's not true? Okay? So a lot of times people come up and they'll get those 3 points. But what happens if I have a line and I have 3 points on that line, A, B, C. Did that form a triangle? No. And so there would be my example that the connection of 3 dots does not make a triangle. Okay, joke time. How do cows count? With a calculator. Who invented the round table? Circumference. Okay, so that's an introduction to inductive reasoning.